This is 2001 Subaru Impreza. Beautiful car, works really well, you can tune it, you can use it as a sports car as it meant to be. But you don't want an old reliable car, what you want is 2014 Subaru Impreza with all the bells and whistles you need. Now if we just look at two boards side by side, you can see that new ones are smaller and they have fewer components on board. You would expect that the new ones are more reliable. Well, they're not. The design of power rails is the same on both of these. It hasn't changed much. We have two transistors that deliver power. These are not linear regulators, these are regular transistors, and the ECM logic is deciding what the voltage on the output should be and when it should be cut. The 2014 version monitors the power draw. If there's too much current going through the rails, it'll cut off both rails. This chip is going to be responsible for that. Now the older model was a lot simpler and a lot more reliable because it doesn't monitor how much current is going to the board. What it has is a crowbar circuit. The power to the entire unit is supplied through this resistor. If the voltage on the input for whatever reason jumps to higher than what we expect, around 12 maybe 14 volts, in this chip we have built-in thyristor, which is going to short this resistor until it blows and the ECM stops working, stops communicating, and all you have to do is just replace this transistor and everything else works. The MCU is safe. On the newer model, since we don't have that, if the voltage grows too high, this chip is going to use a clamp circuit to disable the rails. Not before it will short the MCU. So new models basically short the MCU whenever you have a problem with overvoltage. Now you might ask yourself, why would more than 12 volts go into the board? But that's not the right way of thinking about it. Voltage is a difference of potential. The current flow impacts the voltage. Resistance impacts the current flow. The current flow is dictated by the voltage. So all three are tied together. If you're an owner of Impreza, you most likely either paid someone to tune your car or you bought an equipment and downloaded some software and you tune it yourself. During that procedure, a lot of things can happen, and one of the things that will very likely happen, because I've had a lot of these, is that the ground is going to be removed, which means we still have 12 volts connected to the rails. We produce 5 volts and 4.2 volts. The ground is removed, but the chip is still connected to ground through the outputs, which essentially means our 5 volt logic is going to be hit with 12 volts. That's a gross simplification, but it works. That means that if we don't have a crowbar circuit and just rely on either a clamp or just a power cut regulated or dictated by this chip, we're gonna have a pulse of 12 volts because those are not as quick as a crowbar circuit. On older models, in those cases, all I had to do was just replace this one transistor. On new models, there's nothing I can do. The MCU is shorted. I have to fit you with a whole new unit. That means you're gonna lose a lot of functionality. You will most likely have to reset learned values. You're gonna have to tune it again because you're gonna lose your map because all of that is in our MCU. Now, are those new circuits more intelligent? Perhaps, but not as reliable as an old tested method of just introducing a crowbar circuit at the input. That's why these older ECMs, they can be a lot more expensive than this new crap. These ECMs go for anywhere from $20 to $100. The older ones go anywhere from $130, $150 to $600. Now you see why. They're just reliable. They just work. These are just newer, cheaper to produce, fewer chips, and crappier design, because this was designed by new engineers, likely ones that are not aware of a reliable crowbar circuit. Now quickly, if you don't know what a crowbar circuit is, it's very simple. It is called crowbar because essentially what it does is the equivalent of you taking a crowbar and just throwing it across the power lines. As long as there is voltage in those lines are going to short through the crowbar. You just throw it and you don't operate it, you don't control it. The only way to reset the circuit is to remove the power. For that reason, crowbar circuits use thyristors, not transistors, not triodes, not MOSFETs, thyristors. The reason for that is thyristor, once triggered, is going to remain open and it can take pretty good hit. It can take a lot of current on itself, protecting the rest of the circuit and blowing the fuse. That's its purpose, to blow the fuse. In this case, it blows a resistor. The way it is designed, the design is extremely simple. We just use one Zener diode and a resistor, perhaps, a capacitor and a thyristor. Once the voltage grows to the level that is considered too high, the Zener diode starts conducting, opens the thyristor, and thyristors remain open until the fuse blows. It is specifically very useful when you remove the ground. Thyristor will immediately react and short the power lines until fuse blows. And unfortunately, it is extremely common that ECM suffers problems during tuning, after tuning, and it stops communicating. It just plainly doesn't work. Now, if you have the older ones with this problem, it's relatively quick and cheap to repair it in my shop. If you have the newer ones though, the procedure can take days for me to figure out what exactly went wrong. And then, usually, I still have to give you a replacement ECM because it's not like I can fix shorted MCUs. So just because the car is newer, it doesn't mean it's going to be better. It doesn't mean it's going to be more reliable. But I'm pretty sure you guys already know that new cars are really crappy lately. But now you also know that the electronics design in those cars is subpar. Not something you would expect from a manufacturer of automotive electronics. Hope you guys found this useful. If you have problems with your ECM, you know where to find me. Thank you very much for watching, and I'll see you guys in the next one.